Hey everyone, welcome to this video. Let's talk about diffusion models. So imagine we pass text to a model of cat eating an apple and generates images of cat eating an apple. If you have used AI for turning text into an image, you have likely worked with diffusion model, which is the topic of this video. So, diffusion models are trained by corrupting training images with added noise and then rewarded for successfully uncorrupting the training images by removing the noise. So during training, we take this image of, say, a car in a forest, corrupt it, and then we have the model uncorrupt it to hopefully recover the image of the car in the forest. When the diffusion model gets good at removing noise from images, it can create new images from complete noise by gradually removing noise. So after training, we pass in the text of cat eating an apple, and that noisy image on the far left gets noise slowly removed to end up with a cat eating an apple. Wait, what? How does learning to uncorrupt images eventually lead to a diffusion model being able to create new images? That still seems like magic to some of you, I bet. So here's a way I like to think about it. Imagine you are an artist, and I tell you the above image right here. The above corrupted image should be a cat in New York. I then ask you to clean up the image a little bit. Not a lot, just a little bit. For the corrupted image, the body of the cat is fairly obvious, so you clean that up a bit. It also looks like there's a building behind the cat, a car to the left of the cat, etc. You make these assumptions because you were told cat in New York. So you also start cleaning up these parts of the corrupted image. And this is what diffusion models are basically doing to create new images. And once you clean up this image a little bit to make it look more like a cat in New York, I am so happy with your results. I tell you, I want to hire you again. Here's some money, maybe like $10, etc. I want you to clean up the image just a little bit again to make it look more like a cat in New York. And since you're an artist, you have some artistic liberties or freedoms, so to speak. And maybe this yellow part could be a person or a sign. It's up to you. But you, as the artist, might decide, I think this yellow thing looks more like a sign to me. So I will clean it up and make it look more like a sign or traffic light or whatever. A key point is that generating images is gradual. For both a diffusion model and the artist analogy, it is easier to make an image less noisy than it is to immediately turn noise into a valid image. So, key point, this is not what's happening behind the scenes where it's just complete noise and then a cool image all of a sudden. It's very gradual. We slowly remove noise to create that desired image of a cat in New York. Okay, during training, add noise to your training images so the model knows how to remove noise from both noisy images and images that are almost noiseless. See how good the model is at removing noise, such as with the mean squared error loss function. Update the model's weights with the loss. And a key point that I bolded is the model is not being trained to generate an image. It is being trained to remove noise. And for the third bullet point of update the model's weights with the loss, behind the scenes, this is still what's happening. And it's a diagram we've gone over so many times in this course. We have a model with weights. The weights can be thought of as like the knowledge or brain power of the model. The model creates outputs using the weights, and these outputs can be predictions or a synthetic image, as we've talked about. We use the error slash loss to tell the model how good its outputs are. That error slash loss is used to update the weights of the model. So hopefully we have better weights, better brain power, better knowledge. The model creates better outputs that hopefully have a lower error slash loss, and the cycle continues until hopefully we have a really good model because it has really good weights. And when it comes to generating new images, the model becomes so good at removing noise that if you give it noise, it will gradually remove enough noise to create a new image. Think of this as giving the model some noise on the far left hand side, as you can see in the diagram below, and then lying to the model that the noise is a noisy image of a cat in New York. The model will then slowly remove noise to try and make an image as close as possible to a cat in New York. Now, we've talked about VAEs and GANs earlier on in this course, so let's do a comparison. VAEs are prone to generating blurry images because VAEs use compression, which can lead to information loss. Diffusion models do not use compression and can generate higher quality images. But training diffusion models will need more time and computation compared to other models. GANs are also trying to get two neural networks, a generator and discriminator, to reach an equilibrium, making GANs difficult to train. Diffusion models train for noise removal, which leads to more stable training compared to GANs. And to close this video off, I recommend that you go to the course directory and in generative modeling, download this stable diffusion.ipynb file, upload it, make sure you are using a GPU so that the code runs quickly and not slowly, then go to runtime, run all, and now you can see for yourself an image being generated by the model by taking some noise and gradually removing that noise bit by bit to get our desired image of cat in New York. Okay, that's it for this video. Thanks for watching, and I hope you enjoyed it.